Good morning, students. Today, I shall discuss about relations and functions. You already know about relation and functions by studied by online classes. I already sent two full topic videos. I think you already studied well, but I didn't send the notes. I already told you have to write by watching videos. Sometimes it's not visible. Some problem is there. Okay, some students already written. I asked them. They understand well also. But some students can't understand. But what is the important things in this chapter? Therefore, I once again discuss these relations and functions, which are the points important and what are the problems we'll ask in the examination. So, I will today take relations. First, we discuss about relations. This chapter you already studied in first PU class also. Second chapter relations and functions. Here, first relation is the subset of cross product. Because we studied about cross, we call cross product. What is cross product? If A and B are two non-empty sets, means A is equal to some elements and B also equal to some elements, then A cross B is equal to ordered pair 1 5, 1 6 and 2 5, 2 6. This is the cross product of A and B. Then R is the subset of A cross B. R is the subset of A cross B. It's the relation. It's called as relation. It's a subset of A cross B means R is equal to 1 5. It's a relation R1 or R2 is equal to 2 5, 2 6. It's also a subset. It also another relation. How many relations can you write from this cross product? Number of relations are is equal to number of subset what you write here. That is 2 to the power n of A into n of B, which is equal to 2 to the power n of A is elements of A is 3 and elements of B is 2. Therefore, 2 to the power 6 relations are there in A cross B. Here, A is 3 elements and B is having 2 elements. If A cross B is this product of A into B cross product, we write it as in ordered pair. Then R is the relation which is the subset of A cross B. Then how many relations are there means it is here 2 to the power 6. How can you write 2 to the power n of A, number of elements in A into number of elements in B. It is all studied in the first PU class also. Then I once again record these one. Then domain and range. Domain and range. Domain and range. Domain is the element. First elements in the relation R. Here one is the domain of R is equal to 1 is range of R is equal to 5. So 5. Here domain is 2, range is 5 and 6. Therefore, we can define domain of R is equal to R A such that A belongs to A and AB belongs to R. AB belongs to R. Then range of R is equal to B such that B belongs to B and AB belongs to R. This is the domain and range. First elements in the ordered pair of R are called domain, and second element Y element. Second is in ordered pair itself like that X and Y. X elements are domain and Y elements are called range. In this chapter, we studied some types of relations. Somebody asked the number of relations 6 or 5 or 7. What are the numbers? Not bother about the number of types. Only name. You understand the name of the relations and what is that relation. Types of relations. Here, first type you studied. I don't know what is the in the online class. They also discussed about the types of relations according to your book. First one is empty relation. Empty relation. I already sent the PDF notes also. I think you read, already written. You once again check this one. Universal relation. And third one, identity relation. Identity relation. These three relations are only for examination. Sometimes asked this definition also. In empty relation, its name is say that empty. There is no element in this relation. R is an empty set. There is no ordered pair. Means no element of A is not related with element of A. If A is equal to some elements 1, 2, 3, it's not an empty set. A is a set of elements 1, 2, 3. If it is an empty relation, R is equal to null set. There is no element of A is not related with element of A. R is the subset of A cross A here. Here we take the set, only one set. We find the relation between A cross A, means A cross A is equal to 1, 1, 1, 2, 1, 3. Then again 2, 1, etc. 2, 1, 2, 2. There are 3 into 3. 9 elements are ordered that are in A cross A. But in this set, there is no element, therefore, no element of A is not related with element of A. Universal relation. Here, all elements of A cross A is in this set. Therefore, R is equal to A cross A. Means every element of A is related to the any other element of each element of A. Each element of A. Therefore, R is equal to A cross A. Here, identity relation. I think this one is extra relation I given in the video. Here, identity relation is equal to AA. It's an identity relation. Or R is equal to here 1, 1, 2, 2. It's also an identity relation. Or R is equal to 1, 1, 2, 2. Or 3, 3. It's also an identity relation. It also, if here we cannot write all the elements of A. Means you can write one element. 1 means here image of the image and these are equal. A is having the same image. A is having the image same. 1, 1, 2, 2 or 3, 3 or 1, 1, 2, 2 or R is equal to 2, 2. It's all represented like denoted by IA also. Identity element. A is related, 2 is related to 2 itself. Then only we call it as identity relation. It is denoted by IA. These 3 are only for definition. Then other 4 relations are there. That is reflexive, symmetric and transitive relation, and one more equivalence relation. Fourth one. Fourth one, yeah, reflexive relation. Here, for all A, if AA is belongs to R, for all A belongs to A. For all A belongs to A. Here, it's different from reflexive. Here, we have to write if A is a set 1, 2, 3, then R is reflexive relation is equal to every elements of A is should be right here identity 11. If 1 is not belongs to this one, if you write 2, it's not reflexive. L1 is parallel to L2. Like L1 is parallel to L2. Then L2 also parallel to L1. All parallel lines are parallel to one side. L1 is parallel to L2. L2 also parallel to L1. Here L1 is parallel to L1. It's I will write here. Reflexive. It's AA. L1 is parallel to L1. L2 is parallel to L2 itself. Then L3 is also parallel to L3. You know about the parallel lines. Parallel lines. One parallel line is parallel to that line itself. Therefore, we write it as parallelism is reflexive relation. Then symmetric relation. Symmetric relation here perpendicularity. That means A is the set of all straight lines in plane. If line L1 is perpendicular to L2, L1 is perpendicular to L2, then L2 also perpendicular to L2. You know about the perpendicular lines. L1 is perpendicular to L2, L2 also perpendicular to L1. Therefore, it is a symmetric relation. We can discuss by perpendicular. In transitive relation, we can discuss similar triangles or parallelism also relation can be discussed on transitive relation. Because parallel line 1A here L1 is parallel to L2. L2 is parallel to L3. Here L1 is parallel to L2. L2 is parallel to L3. You know L1 is parallel to L3 also. Therefore, transitive relation is satisfied for parallel. In the same way, it is a set of similar triangles. Relation. Here, triangle 1 is similar to triangle 1. If it is a triangle, it is similar to same triangle. It's a reflex. Here we discuss about the transformation. Here, similar to other triangle. 1, here is 2. Another one is here. Triangle 1 is similar to triangle 2, and triangle 2 is similar to triangle 3. Then again, triangle 1 is similar to triangle 3 also. Therefore, similar triangles also relation also a transitive relation. Yeah. If these three relations are satisfied, then we call it as equivalence relation. Equivalence relation. What is the equivalence relation? R is reflexive, reflexive, symmetric, and transitive, then we call it as equivalence relation. Equivalence relation. The relation is reflexive, symmetric, and transitive. Then we call it as equivalence relation. If three conditions are satisfied, then only we call it as equivalence relation. We discuss some problems on these relations. Today we discuss about relations only. I solved some problems. You already know about solving what type of problems are asked here. I again sometimes revise all these one. I will give you PDF also. Here one more question we asked on this type. A relation on A is equal to 1, 2, 3. Every time you have to write the relation R, you should write the set, which is the set. Relation on A. Here R is the relation on set A. Means A cross A. R is the subset of A cross A. Therefore, we have to write the set. What are the elements included here? 3 elements or 4 elements? Which are there? A relation R on set A, 1, 2, 3, defined by R is equal to 1, 1, 2, 1, 2, and 3, 3. Is not symmetric. Is not symmetric. Why? We are already know about the symmetric relation. If AB belongs to R, then there exists BA also belongs to R. Then only we call it as symmetric relation. Here, 1, 1 is there. 1, 1 is there. This symmetric is 1, 1. Therefore, there is 1, 2, 3, 3 is there. This symmetric also 3, 3. This reverse also 3, 3. But 1, 2 is belongs to R, but 2, 1 is not belongs to R. Yeah, 1, 2 is belongs to R, but 2, 1 is not belongs to R. Therefore, R is not symmetric. R is not symmetric. So, one more question asked in the previous question papers. Then, another question, show that the relation are in the set 1, 2, 3 given by R is equal to 1, 2, 1 is symmetric, but neither not transitive. Transitive. Here, the relation R is 1 to is belongs to R and 2 1 also belongs to R. Therefore, it's a symmetry. It's so. But it's not reflexive because here 1, 2, 3 elements are there. Here there should be 1, 1, 2, 2 and 3, 3. R belongs to R. Denoting we called it as reflexive. There are no elements 1, 1, 2, 2 and 3, 3. All these are in R set. Denoting we call it as reflexive. Here no elements are belongs here. Therefore 1, 1 or 2, 2 or 3, 3 are not belongs to R. Therefore it's not reflexive. And next one is a transitive. Here also, if you write it as a transitive here 1, 2 is belongs to R and 2, 1 also belongs to R, but I have to write 1, 1. First element of 1 and second element of second order is second element 2, 1. Here 1, 1 is not belongs to R. Therefore, it's not transitive. Well, another also 2, 1 is there belongs to R. 1, 2 is there, but 2, 2 is not belongs to R. Here you have to write one of these. You can write here. It's not transitive. Therefore, the one R is not reflexive, not transitive, but it is symmetric. Here, sometimes they ask, give an example of relation like reflexive and symmetric but not transitive, like this. I will give all these that way. One relation you have to write here, one mark. I will give you all the examples here. Give an example of relation. Third one, which is first one is symmetric, but neither reflexive nor transitive. Here, first you have to write the set, either ABC or 1, 2, 3, or 1, 2, 3. Here, if it is ABC or 1, 2, 3, you can write here AB and B. These are belongs to R. It is reflective. It is symmetric because AB is there, BA is there. It's not reflexive because AA, BB and CC are not there. And not transitive because AB is there, BA is there, but AA is not belongs to R. Therefore, it's not transitive. Therefore, you can give this example. Or you can give A is equal to 1, 2, 3. Then R is equal to 2, 3 and 3, 2. It's also a symmetric relation, but neither reflexive and non-transitive. Second one is transitive, but neither reflexive nor symmetric. Here also you have to write the set. Always you write the set, then only write the relation. No set relation is also not there. It's the R is the subset of A cross A. Therefore, you have to write the set, then only write the relation. Here, transitive, but neither relation, reflexive nor symmetric. Here, 1, 2, 2, 3, and 1, 3. Here, AB is there, BA also there, 1, 2, 2, 3 is there, 1, 3 also there. It's a transitive relation, but neither reflexive because 1, 1, 2, 2, 3, 3 are not there. Then not symmetric because 1, 2 is there, 2, 1 is not there. Anyone, 2, 3 is there, 3, 2 is not there. One of the order pair is not there, therefore it is not symmetric. Not symmetric and not reflexive. And transitive here, if 1, 2 is there, if it starts from 2 is not there, you can't check the transitivity property. If only one element is there, if R is equal to 1, 1. If A is equal to 1, 2, 3, then if it's 1, 1, it's not reflexive because 1, 1 is there, 2, 2 is not there, 3, 3 is not there. Therefore, it's not reflexive. But symmetric because 1, 1 is there, it's a symmetric order pair also 1, 1. Therefore, it is symmetric. It's a transitive also because 1, 1 is belongs to R. Again 1, 1 is also belongs to R. Again 1, 1 is belongs to R. I will take the term, next term, also start from 1 and 1. Therefore, it's also transitive relation. Then, next, you have to write all the type of the relations yours own. Here, third one is reflexive and symmetric, but not transitive. Here, A is equal to 1, 2, 3. Here, R is equal to, it's a reflexive. Therefore, we have to write 1, 1, 2, 2, and 3, 3. And 3, 3. 1, 1, 2, 2, and 3, 3. Then, it's a symmetric but not transitive. Then 1, 2, 2, 1. Then 2, 3, 3, 2. Here, all elements 1, 1, 2, 2, 3, 3 are belongs to R. Therefore, it's reflexive. Symmetric, it means 1, 1 is there. It's also symmetric. It's symmetric. Then 1, 2 is there. 1 is there. 2, 3 is there. It's symmetrical. 3, 2 also there. Therefore, it's symmetric. But transitive, not transitive. How it is not transitive? Here, 1, 2 is there. 2 1 is here, 1 2 is there, 2 1 is there, that implies 1 1 is belongs to R. It is transitive. Then 2 3 is there, 3 2 also there, that implies 2 2. It also belongs to R. But here 2 3 2 is there, 3 2 is belongs to R and 2 1 is belongs to R. Belongs to R. Here 3 2 is belongs to R and 2 1. Next term 2, from 2 1. I will take this 2. Its transitivity is 3 1. 3 1 is not belongs to R. Therefore, these orders have not a transitive element, which is 3 1 is not belongs to R. Therefore, it is not transitive. One of the transitive element is not there. You write it as it is not transitive. Then reflexive and transitive and but not symmetric. Here A is equal to 1 2 3. Here the set R is equal to R is the relation A is less than or equal to B. You can take the relation R A B such that this relation R is 1 1 2 2 3 3. You have to write it as because it is reflexive. Transitive also. Therefore, we write 1 2 2 3 and 1 2. Here 1 2 is there, but 2 1 is not there. Therefore, it is not transitive. 3 is there. 2 3 is there, but 3 1 3 2 is not there. 1 3 is there, but 3 1 is not there. Therefore, that it is not symmetric. Last one is fifth one, symmetric and transitive, not reflexive. Here A is equal to 1 2 3. Yeah, A is equal to 1 2 3. R is equal to symmetric. You can write only one term also, it's a symmetric. But transitive, every element you have to write as transitive elements. Therefore, 1 2 1 and 1 1 is belongs to R. Then 2 2 also we have to write. Symmetric and transitive, but not reflexive because 3 3 is not belongs to R. Therefore, it is not reflexive. 1 2 is there, 2 1 is there, 1 1 is there, 2 2. 1 2 2 1 1 1 is there. It's transitive. Then 2 1. Then 1 2 is there. 2 1 and 1 2. It implies 2 2 also there. The same way 1 1 is also there. Therefore, it's a transitive. Therefore, it is transitive but not reflexive because 3 3 is not there. Here in this chapter, one more question will ask. Other is in the relation or relations. There are 3 more questions will ask. It's on the check the symmetric, reflexive and transitive property. That question will ask every question paper for 3 mark question. Sometimes we'll ask 2 mark question also. If there, we will ask 2 property also. 2 relations only. Show that there is a 3 mark question. Show that the relation are in the set of integers, given by r is equal to ab such that 5 divides a minus b is symmetric and reflexive and transitive. If it is 2 mark questions, they will ask 2 relations only. If it is 3 mark question, they will ask 3 relations. Here, first of all, it is the set of integers. It says set of integers means -3, -2, -1, 0, 1, 2, 3. You already know about the set of integers. Here R is the relation from R is subset of A cross A. You know about the relation. Here, which one of the subset here is AB such that 5 divides A minus B. That is, you select these from A cross A are the order where here A minus B is divides by 5. Which are the elements here? Solution. Let A belongs to R. It's a reflexive element because here image and pre-image also image and pre-image. The elements are equal. In this image, pre-image is image. Here two are equal, then only it is a reflexive element. Here A minus A, which is equal to 0, it divides 5 divides 0. That implies 5 divides 0. A minus A is equal to 0. 5 divides 0. Therefore, AA is for all AA belongs to R. For all A belongs to A. Yeah, for all AA belongs to R. Here 1 1, 2 2, 3 3, 4 4, or